Okay, so of course, where is this going to lead now? If we can plot complex numbers on a complex plane, then we can also represent those complex numbers using trig, because if we have a dot on a coordinate plane, we can find a angle and a distance to represent them. It makes sense, right? So how do we do that? Again, this is going to look strangely similar to vectors. However, these are complex numbers. They are not vectors. But if you understand how to do one, then understanding how to do the other should make a lot of sense. So if I have some complex number, a plus bi, in trig form, I can write this as r cosine theta plus I sine theta. Or we can also distribute the r. So this would be the same as r cosine theta plus r I sine theta. R is the absolute value of the complex number. So we just saw that in the previous video, that R, now we're using R as opposed to just calling it absolute value of Z. But R is the absolute value of the complex number, so the square root of a squared plus b squared. You don't need to know this, but it's a fun fact. The value R is called the modulus. The plural for that is moduli. Now you know. A is r cosine theta and b is r sine theta. And again, this stuff should make sense because think about, if I have some point and this is, let's say, our complex plane. So r is this distance, and I know that if this is my point A, B, then this is A, and this is B, and this is theta. So it just makes sense from right triangle trig, which I'm very familiar with, that A is r cosine theta and B is r sine theta. I also know then that tangent of theta is b over a. And again, that's something we saw in the vector unit as well. Another fun fact is that the angle theta is called the argument, where theta has to be between 0 and 2 pi, including 0, not including 2 pi. This is the same word as, but different meaning than what none of you would ever do, and that is disagree with me about the grade, and then we would potentially have an argument. But same word. Another way to write the trig form of a complex number. So notice this is kind of long. So we have r cosine theta plus I sine theta, or r cosine theta plus ri sine theta. So there's a shorthand version of this. And we can just write it as r cis theta, where the cis is cosine I sine theta, or cosine theta plus I sine theta. So either writing it like this, which is a lot shorter, or this are acceptable on any assessments or tests or quizzes. You want to know that they are the same thing. Okay, so I want you to try this on your own then. Plot z equals -2 minus 2i in the complex plane, and then see if you can write z in trig form. Pause the video, unpause when you're ready to check. Okay, so here I plotted the point. I went 2 left and 2 down. I know that this would be my angle theta. So here the A and the B are -2, -2. I found R by doing the square root of -2 squared plus -2 squared, so I got 2 root 2. I didn't show the work because I know from my unit circle that this angle is 225 degrees, or 5 pi fourths. If I didn't know that, I could have done tangent of theta equals -2 over -2. And then here we have to think about, okay, this should be in the third quadrant. So if I did tan inverse on my calculator, it would give me 45 degrees, or pi fourths radians. But because I'm in the third quadrant, that's my reference angle. So then I just write my answer in trig form. Now, I didn't specify, and with trig form of complex numbers, we will see both radians and degrees. So just make sure you know how to do both. And you do, I'm confident in that because we've spent a lot of time on this. So trig form would be 2 root 2 cosine 225 plus I sine 225. or 2 root 2 cosine 5 pi fourths plus I sine 5 pi fourths. If we want to write it in the shorthand version, it'd be 2 root 2 CIS of 225 degrees or 2 root 2 CIS of 5 pi fourths. I want to emphasize, because we haven't talked about this yet, but if we're given the trig form of a complex number, it's very easy to go back to the standard form by just evaluating the trig functions and distributing R. So don't do that if you're trying to write the answer in trig form. But if I evaluate what is the cosine of 5 pi fourths, that is negative root 2 over 2, and then I would distribute 2 root 2 to that, simplify, and I'm going to end up with just negative 2. And the same thing if I evaluate the sine of 5 pi fourths, that's also negative root 2 over 2, distribute the 2 root 2, and it simplifies to negative 2. So that's how we go from trig form into standard form. That should be pretty straightforward. Evaluate the trig function, distribute R. So if you're trying to write the answer in trig form, don't do that. You're just making the problem redundant and going right back to where you started. Moving on, product of two complex numbers in trig form. So if I have one complex number, z1 equals r1 cosine theta 1 plus I sine theta 1, and z2 equals r2 cosine theta 2 plus I sine theta 2, these are two complex numbers. What is their product? Well, if this is in standard form, we have to distribute and then combine like terms. If this is in trig form, it's actually a little bit easier to multiply the complex numbers. So z1 times z2 is going to be the product of the r values, so r1 times r2, and then it's going to be the sum of the angles. So cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So that's how we multiply complex numbers in trig form. If we write this in our shorthand, r1, r2, cis of theta 1 plus theta 2. So this is, again, what we need to understand in order to multiplying complex numbers in trig form. Multiply the r values, add the angles. So I want you to try this on your own. Here's z1, here's z2. Multiply the complex numbers. Pause the video, unpause when you're ready to check. Hopefully you got 28 times cosine of 150 degrees plus I sine of 150 degrees. That's it. Don't do anything else. Don't evaluate these, because then you're getting it back into standard form, and it did not ask us to do that. Another thing I want to emphasize before I mentioned that sometimes we'll see degrees, sometimes we'll see radians with the complex numbers. If we're given something in degrees, leave it in degrees. If you're given something in radians, do the operations in radians. Next thing is division of complex numbers in trig form. So again, this is another operation that is actually a little bit easier to do in trig form than it is in standard form. Remember that the division of complex numbers when we are in standard form is we actually have to multiply the numerator and denominator by the conjugate of the denominator. If we have two complex numbers in trig form, similar to but opposite of the product, here we are going to divide the r values and subtract the angles. So just like normally with division, the order in which we do things is important, because the order of subtraction will be important and the order of division of the r values will be important. But this is our process for dividing two complex numbers in trig form. So I want you to try this. So here's z1, here's z2, divide them, pause the video, unpause when you're ready to check. All right, so hopefully we got 2 CIS of 60 degrees. Z2 divided by Z1, so 8 over 4 is 2. 100 minus 40 is 60 degrees. Again, you're just leaving your answer like that. Okay, so we want to understand the complex plane, be able to convert between standard form and trig form of a complex number, and be able to perform operations in either form. I will emphasize that multiplication and division of complex numbers is a little bit easier in trig form. Addition and subtraction of complex numbers is going to be a little bit easier in standard form. So make sure you know how to do both though. The other thing I want to, again, emphasize, I will emphasize this as much as possible, is the difference that trig form of complex numbers, or complex numbers in general, are not vectors. A lot of our operations are similar. A lot of the notation is very similar. They are not vectors. One of the challenges for this unit, as well as the final, is going to be your ability to recognize the difference between a complex number and a vector so that you know how to do a particular problem.